there is a pattern in raising I to increasing exponents I wanted you guys to uncover. I is the square root of -1. Therefore, if we square it, it should become -1 because any squared number squared becomes itself. And so this pattern actually continues because I to the third, for example, is I times I times I. Two of those i's are going to break off and become a -1, and then we're going to multiply by an I. This will become -I. I to the fourth, for the same reason, becomes a +1. It's I times I times I times I. Two of them make a -1, another two make a -1. Together, those make a +1. And then by I to the fifth, we're back to I, and we can just repeat this. Now this is -1. This would be I to the eighth is +1, and so on. All right, so this is was meant to just get us kind of comfortable with the idea of I. We're only going to use it in a pretty limited capacity for this unit, but by the time we get to polynomials, we'll be seeing a lot more arithmetic with our imaginary number I. All right, here's the anatomy of a complex number. The big thing to take away is that every complex number, pretty much, which means every number that we know of, because even rationals, integers can all be expressed as complex numbers. They all have a real part, which we call A, and an imaginary part, which we call BI. I is our only imaginary number we know of, the square root of -1. So the reason I say any integer can be expressed as a complex number, you just have to make that b 0, and it turns any integer into a complex number. If I want to add complex numbers, it's very similar to adding like terms. For example, this one here is 8 plus 4i. It's just like I added the like terms. All right, so let's solve by taking square roots. For this one here, first thing I'm going to do, I'm going to subtract 10 from both sides. I don't have a b term, so I'll be able to solve this by just taking square roots. Square root of x squared is x. The square root of -9 is plus or minus square root of -9. Here we need to show a little bit of arithmetic to simplify. So we've got plus or minus the square root of -9. I'm going to split that -9 into a +9 and a -1. 9 times -1. I'm going to split up my square root now. X equals plus or minus the square root of 9 times the square root of -1. And now I'm going to rewrite the square root of 9 as a 3, so plus or minus 3, and the square root of -1 as I. And that's how we simplify that. All right, solve by completing the square. All right, let's try this now. I create this structure here. It's got a plus 68. I keep the plus 68. This number here is always half of that b value. And I subtract away that number squared to get rid of my extra. I get x plus 2 squared plus 64 equals 0. Subtract the 64. X plus 2 squared equals -64. This is the beauty of completing the square. It's that if I take the square root of both sides, it will completely cancel out that squared. I'll get x plus 2 equals plus or minus the square root of -64. Let's simplify that. X plus 2 equals plus or minus the square root of 64 times the square root of -1. X plus 2 equals plus or minus 8i, and then we'll move that 2 over. X equals -2 plus or minus 8i. So this is how our answers can be complex. Then we've got the quadratic formula. Let me just do it out loud. -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, this is going to become -6 plus or minus square root 36 minus 40 all over 2, which can become -6 plus or minus square root of -4 all over 2. Which becomes -6 plus or minus, we'll say it's the square root of 4i. That negative can just jump out as an I all over 2. Should become -6 plus or minus 2i all over 2, which can become -6 over 2 plus or minus 2i over 2. And we simplify both those fractions to get to our final answer. Final answer, -3 plus or minus I. All right. Quadratic inequalities. What I want to do to graph this quadratic inequality is dot in a graph for my quadratic. Then I need to make a decision on connecting it with a solid versus a dashed line, and then I need to shade. So let's convert this to vertex form, create the structure. This value here is always half of that value, subtract away its squared. Y is less than x minus 3 squared minus 4. This gives me an a value of 1, h value of 3, k value of -4. Let's dot that in, 3 comma 4. Should go, this is going to go off the graph pretty quickly. Let me double check I haven't made a mistake here. Half that, subtract away its squared. Oh, I put my vertex at the wrong spot. Okay, 3 comma -4, there we go. 3 comma -4, up 1, up 4, and up 9. That's just my squared numbers. I don't have to change it because my a value is 1. Now, I connected these with a dotted line. It's dotted, dotted, dotted because it's just a less than symbol. We don't include the line itself in our set of solutions. And now I've got to shade below this line. So I'll go right up to the line with my shading tool, and then everywhere below it. All right, that's good. Good enough for me. Okay, so this got a little bit rearranged when it was imported. How many different solutions can a linear quadratic system have? You can see in each of these examples, you've got a quadratic equation and a linear equation. The number of systems is the same as the number of possible intersection points. You could have no intersection points. You could have one. The name for this line here is a tangent line. Line just touches a curved line at a single point, and then they can cross 2 times. So let's solve this system. Wow, things got really moved around when this was imported. Hopefully we can see that those are y's. To graph this, I need to convert it to vertex form. So this is going to be y equals x minus 3 squared plus 6 minus 9. X minus 3 squared minus 3. Let's put a point at 3 comma -3. Go up 1, 4, then 9. Goes the solid line. And for the graph y equals x minus 4, put a point at my y-intercept of 4, and then go up 1 over 1. all the way across the graph, down one, backwards one if I want to keep it going that direction. And these two intersect at 2, -2. That's one solution. And 5, 1. So there you go, 2 solutions. All right, solve by substitution. We've got y equals -x squared minus x plus 6, and y equals x plus 3. Plug that in right there. Just a minute. Appreciate that. All right, zeros. After I plug that in, I get x plus 3 equals -x squared minus x plus 6. Subtract x from both sides, subtract 3 from both sides. 0 equals -x squared minus 2x plus 3. Divide everything by -1. And I'll get 0 equals x squared plus 2x minus 3. This looks like it's solvable by simple factoring. Let me just double check. Multiplies be -3, but adds be +2. Yep. We can do +3 and -1. This leads to the answers x equals -3 and x equals +1. Plug those back into our linear equation, and we'll get y equals -3 plus 3, y equals 0, which gives us the ordered pair -3, 0. It's one of our solutions. And we get y equals 1 plus 3, y equals 4. The ordered pair 1, 4 is another solution. Okay. All right, here's a quadratic linear system from the homework. This one is a little bit longer. To solve this, I need to add 3x to both sides. Subtract 1. Now I've got an expression for y. I can plug in for y here and here. And I'll get 4 times the quantity, 3x minus 1 squared minus 114x minus 2 times 3x minus 1 plus 138 equals 0. Got to FOIL this. That'll give me a 9x squared minus 3x becomes a minus 6x plus 1 minus 114x minus 6x plus 2 plus 138. Let's distribute that 4. I'll get a 36x squared minus 24x plus 4 minus 114x minus 6x plus 2 plus 138. Now let's just get all our like terms together, all of our squared terms. I've got a 36x squared. 1 second, I shouldn't write that yet. 36x squared. Yeah, that's my only squared term. So 36x squared minus 24 minus 114 minus 6 it's been negative 144x, and then 4 plus 2 plus 138. It's me a plus 144. This point here, going to divide everything by positive 36, including the 0, but that's just going to be 0 still. So we get x squared minus 4x plus 4 equals 0. Is this factorable? Yes. We could do x minus 2 and x minus 2. That way they multiply to be positive 4, add to be negative 4. This gives us, right up over here, x equals 2. We can plug that in to that second equation. Negative 3 times 2 plus y plus 1 equals 0. Negative 6 plus y plus 1 equals 0. Negative 5 plus y equals 0 plus 5 plus 5. Y equals 5. It's going to lead to our final answer, 2 comma 5. It's just the one intersection point. So it must be a tangent line. One solution. All right, let me go through this one. This one we're going to stop short because we're going to reach a point where we realize this has no solutions. So here's what I get after I do the substitution. Let's see, 16y. Try to do the foiling. After I do the distribution, I'll get 12y squared plus 48y plus 48. All right, combine like terms. 17y squared, 48, negative 8, and then negative 11 should be 29y. 48 minus 16 minus 17. We'll get a 15. But now let's see why this has no solution. So for this to have a solution, the discriminant needs to be greater than 0. The discriminant is what's inside the square root of our quadratic formula, b squared minus 4ac. Let's plug those values in now. 29 squared minus 4 times 17 times 15. And that equals negative 179. So what I'll say here, negative discriminant means no solution. All right, real world problem. Where is this cannonball going to intersect this slope? All we have to do is plug in or do a substitution, combine like terms, we get 0.15x equals 2 plus 0.12x minus 0.002x squared. Let me subtract this from both sides, get it into kind of a standard form. It's 2 to figure out what I need to multiply to get my a value to be 1, I'm going to do 1 divided by negative 0.002 in my calculator. I get 500. I'm going to multiply everything by 500 to simplify this. So we get 0 equals 1,000. Or, 1,000. Minus 15x plus, or let's make that a negative 500. So negative 1,000 plus 15x plus 1x squared. Rearrange this real quick. We get x squared plus 15x minus 1,000. Let's see, is this factorable? Factors of 1,000. 1,000 divided by 50 is 20. Those are 30 apart. Let's do 1,000 divided by 25. That's 40. I think that's going to work. So we get x plus 40 and x minus 25. All right, this gives us x equals negative 40 and x equals 25, but we can rule this out. There's an extraneous solution. We only want the positive answers. Let me plug in 25 for x in our second equation, y equals 0.15 times 25, 3.75. So y equals 3.75. So where does it land? It lands at the coordinate 25, comma 3.75. And I don't know what those units are in. So it's just a coordinate. Maybe it's feet. All right. This is our last problem. Nope, we actually got a system of quadratics after this. Okay, where does this circle intersect this line? This one I know is going to give us somewhat crazy decimals. That's okay. We'll just deal with that when we come to them. How do I want to do this? Is there a way to do elimination maybe? All right, no guarantee this is going to work, but I'm going to try to do elimination. Let's multiply this one by 2. We get 2x squared plus 2y squared equals 50. And let's multiply this whole one. Now, if I multiply it by x, I'll get an xy term. Oh, we got to do substitution. It's the only way. I don't see a great shortcut for this problem. I know it ends up with some long decimal answers. I don't feel like anyone's going to benefit from me doing this problem. I'm going to skip it. Let's just do this one so we can get down here. Convert this to vertex form. Half that value, keep my plus 3, subtract away that number squared. get y is greater than x minus 2 squared minus 1. Go to my vertex, 2, negative 1. From there, go up 1, then up 4, and then up 9. I'd be off the graph. So, oops, I was about to connect it with a solid line, but I know I need to actually connect this with a dotted line. Do that. All right, I need to shade above this line here. So I'll shade that in. Let's convert this one to vertex form. By storing the negative 1 over here, I've got an x squared minus 4x plus 1 becomes x minus 2 squared plus 1. Subtract away our extra. Ultimately, we get y is less than or equal to negative x minus 2 squared. That was a negative 3, but we multiplied by negative 1, so it becomes a positive 3. So I go to 2, 3. Put a point, then use my a value to get the rest of my points. Down 1 over 1. Then down 4 from the vertex. And then down 9 from the vertex. This is an or equal to, so I want a solid line for these. I want to shade below this, but I only have to shade what's also been shaded in the other one. So it's just going to be this region in the middle here is our overlap. The rest of this is all going to get erased. So there we go. There's just our overlap. Let me fill in my again here. Really clear boundaries. A little bit more highlighting. There we go. All right.